is to help attendees understand what the most tools provide, the natural limitations of even the best tools that are out there, and how to recognize when you need more than a performance monitoring tool, particularly in a Windows SQL Server environment. And I'll be talking about 3 real-life examples that show kind of the limitations of what tools can do. And at the end of the presentation, I'll provide a checklist that will enable you to figure out, which arena you're in. Are the tools doing enough for you, or do you need some additional help? First of all, the issues and limitations. Number one, real-time monitors have to limit their presence on any given system, whether it's a collection machine, particularly if you monitor lots of machines, or a monitored one, because otherwise they either exacerbate or create new problems. And the disk footprint can also, if they've monitored too much, can get very large very quickly. For example, one server I deal with can generate 20 gig a day, and that's with a moderate collection. That's not even using some extremely detailed information. So you can see very quickly, if they aren't very judicious about how they handle these things, they're going to have a problem. So because of this, they have to make certain design compromises and also leave out some data, or at least take it at an extremely high level. Examples of these compromises are that you can't collect the most voluminous metrics. So, for example, things about indices, because this kind of data mushrooms very quickly. Short duration queries are also a problem, because if you have a query that is taking a very short time, but there are hundreds of thousands of them, that still can be problematic. But for them to monitor that, they wouldn't really be able to sustain that, and that again gets back to the data footprint problem. Locking and caching, those are 2 areas that have plagued Profiler for years. People inadvertently turn those on and create not only gigantic traces, but also really hurt the systems they're watching. The other thing is, when it comes to parsing, the way with queries that are submitted with parameters, whether they be stored procedures or ad hoc queries, you have some kind of query parsing. Some of the packages have query parsing that enables them to replace the parameters, the specific parameters like John Smith, with a generic token that will then allow you to summarize the data. Without this, cumulative effects are impossible to detect. For example, if you have 150,000 executions and they perform a total of 3 billion reads, but it's only 20K per execution, a 10% reduction in the work that this query does would eliminate 300 million reads. So it's something, when you get on that scale, even though the individual query may not have a problem, there may be room to improve it, and the overall impact on the system can be fairly large. When it's thoroughly performed, parsing can be very resource intensive. And so the more queries you pass through a parsing engine, the worse it gets. The other thing is sometimes queries are only parsed up to a point. Maybe the beginning is parsed, and there are many queries I've seen where they're 7,000, 8,000 characters long. And when you have a query like that, and a lot of times the where clauses or the parameters are all at the end, you end up making all the queries look the same even when they're not. I've actually had join clauses removed if I didn't go far enough out in the query. So this is something, again, that a real-time monitor has this issue where it's through no fault of their own, they have to keep that footprint down. And that's part of but one of the side effects is that problem there. The other thing is in-depth collection of various metrics, such as event tracing for Windows, which is used for very detailed disk analysis in terms of disk patterns, but also what files are open, what files are being used in terms of the system. So if you have a disk that's 22% busy all the time, why is that? You can use event tracing for Windows to figure out exactly what's causing it, what the underlying issues are. Maybe it's a bad driver, things of that nature. Number 2 is correlation of patterns and metrics from disparate sources. So perfmon, SQL trace, and literally hundreds of SQL internal views are combined into coming up with a cohesive picture of what's going on in the system. That's difficult for a program to do to any extensive degree. And again, it requires that the authors really know what they're doing, but also be able to codify that kind of issue. And the other thing is the tools are great at graphically and tabular displays of individual areas. But again, it's very difficult to say, well, if this is happening over here and that's happening over there, and this metric and that metric and that metric, putting those three together, that means X. So sometimes we have to pull together 10 to 20 metrics from all different areas to be able to figure out what's going on with the system and get a complete analysis of it, particularly when the problems are vague, such as the sluggish system, that kind of thing. Interpreting results. This again it gets back to the knowledge base of the authors, but also how far they can take it and put that into code. It becomes almost an artificial intelligence kind of problem, and how far you can take it depends on all kinds of things. Developing conclusions and devising solutions is the same problem. All these things are very difficult to put into code and to come up with really good and accurate explanations for things. Number 3, due to the level of abstraction between Windows and the disk hardware today, monitors know very little about what really is going on underneath, and particularly in the disk subsystem. Sometimes they can be provided with outside information when it comes to controllers or whatever. They can see if some of the hookups, but for the most part, they don't know how many disks are in any given LUN. They don't know exactly how the LUN is configured, particularly what kind of RAID it's using, how many, what the configure, because all that's done at the hardware level, and they really don't have access to that very often. Are the LUNs solid state? Is that because solid state in general should be faster? There are cases, though, where depending on the connectivity, it may not be all that much faster. How are the writes handled for a given LUN? There are ways to configure the caching algorithms to bias the behavior one way or another. And how much cache is on a given controller. So if you have a small amount of cache on the disk controller, that changes what it can do in terms of throughput and things of that nature. Again, all these issues to get combined to where disk subsystem analysis becomes very difficult. It's also difficult for us, but we tend to ask all these questions, and unless the program has been made aware of them, it's difficult to know how the program would interpret some of that data. So the other thing is that monitors report data, but again, they don't diagnose the multifaceted issues. And it sounds like kind of the same thing, but it mainly leverages the experience level of what a person that's been in the business for a long time can do. And so, again, there's only so much that you can put into code and say, well, if these things happen in this order or this and this, and then sometimes because there are always exceptions to every rule. I mean, some of the basic rules about maybe response time from the disks is X number of milliseconds or higher. Sure, those are easy to do, but in terms of figuring out what the root causes are, those aren't so hard, and that require significant experience. What monitors usually detect? The query ran longer than a certain threshold. It did a large number of reads. Processors were busy. Queue length, some monitors look at queue length. Some do some more things about the transfer times. Just depends. Sometimes they do it in aggregate, or at least report it in aggregate. Others report it as individual LUNs. It just depends. Windows available memory being too low. That's a pretty easy one to see. SQL Server memory pressure was above some threshold. There are two metrics that you can look at, and I'll talk about one of them later, where you can actually figure out, is this pressure, is SQL Server under pressure, or is it doing well? One of the favorite ones that most of them have are one query was blocked by another query. Deadlocking, blocking, various things like that. They're pretty good about that. And the areas for which SQL Server was generally waiting, for example, parallelism, I/O, things of that nature. So those are pretty much things where the monitors are all pretty good at. The things that monitors quite often miss are attributing, let's say you have a stored procedure that calls 4 select statements in it, and 2 of them are bad. And so you may see the stored procedure is bad, or you may, depending on the level of reporting, or you may see an individual statement is bad, but you won't see that those two of those statements go back to the stored procedure. And if you have literally hundreds of thousands or millions of queries coming through a system, it gets to be very difficult to figure out where they came from. Sometimes they came from a specific user, a specific server. If they go above a certain threshold, you'll probably pick up the individual statement, but you may not be able to track it back to all the different people and parameters and things of that nature. Since monitors often record completed events and not active events, if you have a really long query, I had a customer once that did a query that ran for 12 hours, and it usually ran in 2, and they were having trouble locating it in their monitor, and it was because the thing had never finished. Sort warnings, attributing those back to the queries that caused them. This is pretty uncommon to see, and it's something that can be very important. Which queries are the ones causing the hash warnings or the different kinds of serious sort warnings that say the sort is doing way too much work? And again, getting back to the parsing, I think that's a real big issue because I deal with customers that have very high volume systems, and when you're having that situation, it gets to be very difficult to do all the parsing and everything on the fly for sure. So a lot of times they'll take shortcuts necessitated by the design, and that will keep it also keeps them from seeing everything in total. So you can't do things like cumulative sums and average for executions, durations, CPU times, reads, writes, whatever. Being able to develop a time series. When did these queries run? How much work did they do in each hour? That kind of thing, especially collectively. I'm not saying in any individual query, but when they look at the collective effect. The work that performed by queries when they do hints. So there are certain that maybe they use tab lock, or they use update X, or different things, different key query hints that make them so that they don't understand what's going on. The queries that are recompiled very often and why they're recompiled, and maybe we can do something about those. Disk information that is often missed is things that are important about percent idle. SQL Server is a very I/O intensive application, and once the LUN goes to 0 idle, there's no more work that's going to get through it. And this is something that sometimes people will look at queue length and not look at idle, or look at response time, that kind of thing. The other thing is you have to look at and consider the differences between solid state and rotating disk. And generally, solid state will be better, but maybe it has a certain threshold that after that it doesn't work right. The other thing is, getting back to the conclusion issue, is that sometimes the response times won't make sense. You'll have 300 milliseconds, but you're only doing 2 megabytes a second or very few IOs. And a lot of times it can be because there are other systems using the SAN, and it's through no fault of this server that you're watching that the problems exist. They're just, basically paying the penalty for that. I recently had a customer that had an Exchange server and a SQL server sharing the same SAN, and they happened to share the same physical units. And whenever Exchange fired up some maintenance activities, SQL Server's performance got terrible. So some products don't monitor I/O wait times for the SQL Server files, and the read-write ratios are not often considered. So when you have a RAID 5 LUN, you should only have about 10% of the IOs should be writes. These kinds of numbers are not always considered and evaluated. Memory information that monitors often miss. Database lookups, are they caused by a small number or a large number of queries? A small number is easier to find and tune, obviously, because you have a few queries doing a lot of work. The large number of queries means that you've got a query that probably is okay but could be tuned further, and I've given you a couple of examples of those already. And overall, that can reduce have a significant impact on your system. Also, how much reuse are you getting out of your database buffer pool? Database lookups per physical database read. As you get closer to a one-to-one ratio, basically tables are being read in and not being reused. So these are things that are quite often missed and are important to look at. So let's give you a couple of examples here. The users report, these are actual examples. The users reported the system was sluggish daily between 11 and noon. It's a third-party application. We really weren't given any information, specific queries or specific screens or applications or anything. So what is to blame for the sluggish system? There are bad queries, bad query design. Are you trying to grind through too much data being brought back over the network? Is the processor complex overloaded? Are the disk subsystem having problems? Memory, not enough memory, kind of all the things we've talked about. This is, again, kind of a checklist of areas where you can look at when you're trying to solve your own problems. Slow network. Maybe you've got a whole bunch of routers that are old and you don't have the speeds that you should, and there's a lot of data flying over the network. Indexing structure, is it appropriate? Do you have redundant indices? Do you have all kinds of other issues going on, maybe missing indices? And then the blocking one that we've talked about before. So the problem is people don't know exactly where to begin the search, and they don't know exactly what the most cost-effective solution might be, or at least the things to attack first, bang for the buck kinds of things. What the monitors show for this period was processor usage was not really any different, and they were in the 40s, 30 to 40% range, nothing exciting. Disk usage really didn't change much. There was no memory pressure. Disk usage overall did not change much. There was no memory pressure. The network utilization was very low. More queries over 5 seconds occurred between 11 and noon than the surrounding periods, which you kind of would expect because the users were saying the system was sluggish. Interestingly, the worst queries occurred at 11 o'clock and 12:02, and both times it was the same query and it ran for 2 minutes. So I suspect that this was part of the reason why they knew it was from 11 to noon, because these queries ran about that time. What the monitors don't show is that 73% of all the queries that ran for at least 5 seconds occurred in this interval. Now you will have seen the graphs generally that, okay, there were more of them, but the percentage-wise, you won't know. 70% of them performed more than 10,000 reads occurred in that interval. 62% of the ones that did more than 50,000 reads. And 70% of the ones returned more than 5,000 rows. So you can see there was generally more work done in that period than other periods. Also, interestingly, the page lookups, the metric I cited before, per page read dropped significantly, and there was also a jump in page reads per second compared to the surrounding intervals. There wasn't anything large enough to where the disk statistics showed any problem, but it definitely indicated that there was a lot of data that had not been in the SQL Server buffer pool and was now brought in. Example 2, SQL Server was peaking at about 520,000 lookups per day, and per second for the day, and sustained rates range between 250 and 500,000 a second. So again, you can see that these rates are pretty high. And what queries are doing all the work? And the users are complaining, but this customer was going into a very busy season, and the trend was a little troubling, and they were worried that they were going to have enough capacity to handle and when the load really got big. So the monitors showed the following. All the hardware looked good. Maintenance and historical queries were running a long time, but these were overnight. Everything else appears to be okay, so there's nothing really demonstrative coming out of the monitors. Some issues that were found: 4 queries that were executed 960,000 times, performed almost 35 billion reads. But the average durations were, as you see there on the screen, sub-second, less than half a second. Now normally you'd think, who cares? But the thing you have to remember is that the collective effect here was 35 billion reads. That's a lot of work. The worst one was executed 62,000 plus times and performed almost 15 billion reads and averaged about 240,000 reads per query execution. The indices were fine, but there was still some optimization that was required. The SQL Server didn't see any problem with anything. Interestingly, that even with those rates and those high levels, even a 7% reduction would reduce the number of reads by over 1 billion, and that's a lot of reads. It turns out that we did an index optimization project for them, and I was able to create some indices that dropped that number by 99.6%. And so you can see that even though things appear to be good and that there's no room for improvement, there often can be. And again, an experienced person can provide that. And these are things that the typical monitor would have no reason to collect. And other queries were reduced also by the same project. Index usage statistics, they're not usually captured because, as I mentioned before, they can be very large, but they're extremely useful for determining things like unused indices, unnecessary indices, indices that are scanned instead of looking at them like singletons, single lookups, missing indices, which tables need the most help when it comes to index rework, so you're not trying to redo the whole database, you're just doing part of it. And then other detailed usage behavior, locking, waiting for locking, things of that nature. There's a myriad of performance metrics out there for indices. So here's an example of an actual unused index report, and you can see that these are all for the same table, table 1, and there are 4 indices, but one of them isn't used. And that one index, though, has been updated over 10 million times. So you're updating this index, and you're never using it. So this is, again, a very valuable kind of scenario. And if the instance has been up for a long time, there are ways to figure out whether an index really was used in the last 3 or 4 months, whatever, 5 months. I've got one customer, I think, that set it up for almost 6 months. That one, that can give you some very good data as far as what's being returned. Another example of a similar kind of information is this is a summary and index overview by table. So it shows you how many indices are on the table, how many are redundant, are not needed, how many are unused, how many are missing as determined by SQL, and then the percentages and how many rows you're dealing with. And I've highlighted a few of these. You can see that some of these have either, like the first one with the orange has 10 missing indices. You've got the second orange one has 12, and the third one has 7. And then you've got other ones that have unused indices, 25, 67, 50% of them are unused. So these are things that can be very helpful to you in terms of determining overall what you should do as far as tuning indices. And the final part of this example is what the total improvement measure as estimated by SQL, what it's going to be and how many indices have been recommended. And the interesting thing here is that this improvement measure is kind of a relative number. It's not something that is an absolute in any way, but you can see that some of these have fairly high numbers, and it's important to note that some of these missing indices may be able to be combined into one generic kind of index that will handle multiple recommendations. But nonetheless, this gives you an idea of exactly how much things can be improved, and these are things that monitors typically don't capture. So how do you tell when tools are insufficient? Well, basically there's a wide diversity in what the tools can do, so you really need to understand what the capabilities of your tool happens to be. And also what your experience level is. The more experience you have, the more powerful that tool is going to be in your hands. the less experience you have, you may not be able to get as much out of the tool, or it may tell you, oh, this metric is 10,000, but you don't know whether that's good or bad. So a checklist about what to look for. So when you have problems, look to see if the processor is pretty busy. See if you're getting high transfer times out of your disks. It's really important, and also to understand whether their reads are writes. If you're only getting bad response time on the disks out of writes, then that could mean that you're doing RAID 5 and you're doing too much writing. Memory pressure. If Windows Available gets below 1 gigabyte, you typically, that's in this day and age, that's pretty iffy. So especially if you have anything happening outside of SQL's environment, like loading in files into SQL Server, that kind of thing, you need extra memory for Windows for those kinds of things. Is SQL Server memory pressure present? Page life expectancy below 300 seconds. That's generally a good value to use. Please note that this is a weighted average. It's kind of it's a number that is not instantaneous. So it tends to drop pretty quickly, but it tends to rise fairly slowly. And so you just have to keep that in mind when you're watching that number. High weight statistics, particularly in the areas of parallelism, I/O, and locking. If you see lots of that going on, then you've got some issues. Parallelism means that a query was broken up into lots of pieces, and then some of the pieces finish before others, and so you're waiting for all those pieces to finish so you can combine the results. This generally means that a query is really big, and it may be so big that it could be hurting the system, or at least not designed properly. Obviously, long query runtimes or resource usage, you want to look for those. If you understand how to do query plans, you want to review the query plans and determine whether there's too much work being done or whether there's some indices that are missing. And then the obvious one about queries being blocked by other queries. So if you find that the checklist doesn't identify the problem, or you find that you have all kinds of issues going on, you probably need some outside help. If you suspect that if you see some strange disk behavior, some strange memory issues, things you can't explain, maybe memory, available memory is getting really, really small, and then it gets big, and then it gets really, really small and big. You almost have the sawtooth kind of thing. Those are strange problems that can be addressed. Poorly configured SANs and SQL servers. Those are things, again, that people like us can help you with. And application issues, maybe the application's not doing things in a proper manner. Maybe it's making too many trips to the database. I had one application I worked with where every field, a trip was made to the database for every field on the screen. And obviously that created a lot of overhead. Indexing issues, whether it's missing indices, too many indices, redundant indices, things of that nature. I had a customer that had, through some very strange sets of circumstances, they had problems where they had lots and lots of indices on a table, so many that it caused SQL Server to come up with an inconsistent query plan pretty much every time they ran these complicated queries. If you have difficulty finding an intermittent query problem, like the sluggish period one, sometimes that gets to be very difficult. Those are very difficult to figure out, and you have to look in lots and lots of places and collect lots and lots of data to find them. Our collection suite is very low overhead. It does not have an installed code file, but yet it's very complete, and the analysis is done off-site so that I can do far more in-depth analysis for any given problem. And that's it for today, and I appreciate your attending. And if you have any questions or comments, please be sure to give us a call. Thank you very much.